Okay guys, I have a problem here, a projectile motion problem for your review. So this one is end of chapter number 4. So this one says, in the Olympic shot put event, an athlete shows the shot with an initial speed of 17 meters per second at a 40-degree angle from the horizontal. The shot leaves her hand at a height of 1.8 meters above the ground. Question is, how far does the shot travel? All right, so pause the video and work it out, and then answer the question in the window that's going to open. All right, so the first thing that we need to do is obviously do a sketch of this situation. So here's my sketch. I have the athlete there holding the shot. The shot is going to be launched with a speed of 17 meters per second. It's going to have an initial angle of 40 degrees, and the initial height above the ground is going to be 1.8 meters. So that shot, after it leaves the hand of the athlete, of course, is going to follow a projectile trajectory. It's a projectile, so the trajectory is going to be a parabola, and the shot is going to hit the ground at a distance delta x from the athlete. And the question is, what is delta x? That is the task that you have to do in this problem. So we're looking for delta x. Now, before you start any calculations, I would suggest that, given that you have the speed and the angle of the initial velocity, to calculate the components of the velocity, because for projectile motion, you're always dealing with the x component and the y component of the velocity. You never deal with the speed of the object directly. So we're going to calculate the x component of the velocity and the y. So the x component is going to be the magnitude 17 times the cosine of the angle, 40 degrees in this case, and you get 13.02. For the y components, you'll get 17 times the sine of 40 degrees, and that gives you 10.93 meters per second. So we have those values that we're going to use in our equations. Now, which equation are we going to use? So what I propose here is to use the equation delta y equals v initial y delta t minus 1/2 of g delta t squared. In this equation, we know delta y because if we think of the initial point being the release point and the final point being when the shot hits the ground, then the delta y is actually known. It's minus 1.8 meters. We know the initial velocity in the y direction is 10.93. We know the value of g, of course, that's 9.8 always. So in this equation, we know everything except for the amount of time that the shot spent in the air. So we're going to calculate that amount of time first. So replace the values. So delta y is minus 1.8 meters. And you might be wondering why the minus. Can I just put 1.8? The answer is no, it is really minus 1.8, and if you don't put the minus, your answers are going to be wrong. The reason why it's minus is because delta y means final vertical position minus initial vertical position. Your initial vertical position is 1.8, and your final is 0. That shot is going down to the ground, so your final height is lower than the initial. Therefore, the difference between final and initial is a negative number. This is very important. So delta y is minus 1.8 meters. We already calculated the y component of the velocity. That's why that was the thing that we did first. 10.93 times delta t minus 1/2 of g is 4.9, and multiplied by delta t squared. So we have, as you can see there, a quadratic equation. So the best thing to do is to write it in the usual form ax squared plus bx plus c equals 0. So doing that, you get putting all the terms in one side, and then that equals to 0 gives you 4.9 delta t squared minus 10.93 delta t minus 1.8 equals 0. So that allows us to identify a, b, and c in your quadratic equation. So a is 4.9, b is minus 10.93, and c is minus 1.8. So using the quadratic formula, delta t, in this case, the solution to the quadratic equation would be minus b, so that's 10.93, plus or minus the square root of minus b squared, so minus 10.93 squared, minus 4 times A, 4.9, times C, minus 1.8, all that divided by 2 times A. 2 times A is 9.8. All right, so plugging in, doing the mathematical operations inside the square root, you get those numbers. And the argument of the square root is 154.75. So the delta t values, there's two delta t values, two roots of a quadratic equation, unless the square root was 0. So one root, you write it by using the plus sign, the other root, you get it by using the minus sign. So one root will be 10.93 plus 12.44 divided by 9.8, and the second root will be 10.93 minus 12.44 divided by 9.8. Notice that the second one is going to be a negative number because 12.44 is bigger than 10.93. 12.44 is bigger than 10.93. So you will get a negative number if you use the negative sign between them. So that a negative time is not physical for this problem. So we're going to use the plus sign. That's our only solution here. And when you use the plus sign, you get 2.38 seconds. So 2.38 seconds is the amount of time that the shot is going to be flying in the air. Now with this time, we're almost ready to find the final answer. The equation that tells us the horizontal displacement of a projectile is delta x equals v initial in the x times time. So the total distance traveled by the shot will be the initial x component of the velocity times the total time of flight, which is what we just calculated. So we're gonna plug in that the initial velocity in the x direction is 13.02. The time we just figured out is 2.38, and you multiply those two numbers, you get 30.98, and you can round that to 31 meters. So the answer for this problem will be that the shot lands 31 meters away. All right, now one thing that I want to do before I finish this video is something that maybe it's in the back of your head, or you're actually asking yourself that question, or at the moment when you saw the equation you were asking it, which is, why did I start with this equation? It seems like a valid equation to do, but there is so many other ones that you could choose from. Why did I choose this equation? If you don't know, if you cannot figure that out, of course, that would be worrisome. So let me explain to you why did I choose that equation. Worrisome because, of course, in an exam you're not going to have anybody telling you which equation you need to use. So let me explain why I chose this equation. The reason why I chose this equation is because what we're looking for is delta x. So I chose the delta y equation because I'm actually hoping to get to delta x is the question that we need to answer. So why is that? What's the connection? So if you look in your formula sheet, you'll find three equations that are applicable to constant acceleration. Projectile motion is an example of constant acceleration. That shot, while it's in the air, has a constant acceleration. It's 9.8 downwards. So for constant acceleration, you have three equations in your formula sheet, and one of them is the one with the velocity v. For projectile motion, we write it as vy final equals vy initial minus gt, but that came from the equation in your formula sheet that says vsf equals vsi plus as delta t. That's how you see that equation in your formula sheet. The S in the formula sheet stands for X or Y, depending on whether the object is moving in the X direction, in the Y direction, or maybe in both. So for looking at the vertical motion of the shot, we need to replace S with Y, and the acceleration in the Y direction is minus G for a projectile. So replacing AS with minus G and Y and S with Y, you get the equation on the left, Vy final equals Vy initial minus G delta T. So that's one of the equations that would apply for the projectile motion that we have in this problem. The second equation that you can take a look at is delta Y equals Vy initial delta T minus 1/2 of G delta T squared. That's the one we actually ended up using. But just to remind you, this equation is coming from the equation in the formula sheet that says delta S equals Vs initial times delta T plus 1/2 of as delta t squared. Again, replace s with y, and notice that ay is minus g, and that's the equation you get, delta y, etc. And the third equation is vy final squared equals vy initial squared minus 2g delta s. Again, you know how to get that one from the formula sheet. So those are the three equations that apply for the vertical motion of the shot. But the shot also moves in the horizontal direction. In the horizontal direction, the equation that we use is delta x equals vx times delta t. Why this equation? This equation also comes from the formula sheet equation that says delta s equals vsi delta t plus 1/2 of as times delta t squared. But remember that in the horizontal direction for a projectile, there is no acceleration. Ax is 0. So if ax is 0, this term here is 0, and you get delta x equals vx times delta t. Okay, so notice that the quantity that we're looking for in this problem is delta x, and the only equation that has delta x in it is delta x equals vx times delta t. So what that tells you is that, well, you know vx is written on top, is 13.02. So what this is telling you is that there is no way you can answer this question unless you find how much time the projectile was in the air. You absolutely need to find delta t, the total time of flight for this projectile. Okay, so what that means is that, well, you only have 3 other equations that you can find delta t from. There is no more equations than these 4 that apply to a projectile. So the other 3 equations are right there on the left. They are the equations that apply for the y motion of the shot. Out of these 3 equations, which ones involve delta t? Remember, I just told you that delta t, you absolutely have to get delta t. Find it somehow. So out of these 3 equations, there's only 2 that have delta t. Now, the one that we ended up using was the second one. And that's because we needed to use this piece of information that is very critical. The shot's initial height was 1.8 meters. The first equation does not use the 1.8. The second equation uses the 1.8 meter initial height. That's your delta y. Remember that it was minus 1.8. So that tells you that you have to use that equation. The equation that you need to end up using is delta y equals vy initial. We have that value, it's 10.93. Delta t, we're going to find it from this equation. G, of course, is 9.8. So that's the equation that you can use to find delta t. Right? That's the equation that we use to find delta t. And after you find delta t, you can plug it in the equation for delta x, and that solves your problem. Okay? So this is the kind of thinking that if you don't see which way to go, this is the kind of thinking that you need to apply to solve these kind of problems. See what you're looking for, which equation involves the variable that you're looking for, and go from there. All right, guys, that's it for now. I'll see you in the next video.